Question number 2 on practice test A starts with the sign of 11 pi over 12. I'm not great at working in radians. Let's change that 11 pi over 12 into degrees. I want it in degrees. I have it in radians. I need 11 times 180 divided by 12. How many degrees are we looking at? 165 degrees. I need the sine of 165 degrees. That's not on my unit circle. How can I break that up into two values that add or subtract to get to 165? 135 plus 30. 120 plus 45. Those are two great answers. We could do 180 minus 15, but we don't know 15. You can choose either of these two values, whichever one you want. I'm going to choose this 120 and 45. You can choose either one, though. They're both great ones to use. So I'm going to break this up into the sine of a sum of two angles, 120 plus 45 degrees. Our equation, our formula for a sum of angles using sine, it's the second one up on the poster that we have around the room, tells me I start by bookending sine at the beginning and the end, cosines in between, and the same sign that I'm using here, so I'm going to have addition. And then I do angle 1, angle 2, angle 1, angle 2. So sine 120, cosine 45, cosine 120, sine 45. From here, most people tend to use their calculator, so let's go ahead and do that. Check that you are in degree mode on your calculator. And then I'm going to calculate sine of 120. That's the first value that I have. I'm not going to write down 0.866. What am I going to write down? Square root 3 over 2. Cosine 45. I'm not going to write down 0.707. What am I going to write down? Root 2 over 2. I continue that to fill in all of my values. Once I have all of my values substituted, I'm ready to start multiplying. My first fraction, remember when I multiply fractions, I multiply straight across. Root 3 times root 2 is what? Square root 6. 2 times 2 in the denominator is 4. A lot of people are still putting 2 on the test. Make sure you recognize that we are multiplying the denominator as well. Now I have a negative times a positive. We'll have a negative going on here. Negative square root 2 over 4. And my final answer, I have I have a difference of two fractions with a common denominator already. Square root 6 minus root 2 over 4. And I can't simplify that anymore. That one's set to go. So you see how that's a little bit nicer than that first problem that had a lot of steps. This one's looking a little better for us. Questions on number 2. I think you'll like question 3 even better. It asked me to find the tangent of the cosine of the angle whose cosine is negative root 2 over 2. Do I need to be in degree mode or radian mode for this? Write down here that we can be in either mode. Since the final question is not asking for an angle measure, it doesn't matter which angle or which mode I'm in. And from here we're going to just type in some values. Tangent of the inverse cosine of negative square root 2. Make sure you close your parentheses or hit the right arrow button after that square root. And when you hit enter, are you getting the same thing I am? That's it. That's our entire problem. You like that one? Since we're dealing with, check that you're doing a square root and you're closing your square root. Some of your answers as you reach this question may be a decimal that we are familiar with. So if you're finding an answer where it's 0.866, you know that you're not going to write down 0.866. What are you going to write down instead? Root 3 over 2. All right. So take whatever value you're getting. If you can put it in exact form, do it. If not, leave it the way it is. This one happens to be a very nice, beautiful negative one. Let's continue on. We're doing great. Question 4 starts me off with a cosine value and tells me that we are in a certain quadrant. What quadrant are we in? Awesome. Awesome. So we're somewhere between 180 and 270 degrees. We should be in quadrant 3. It's asking me for the value of cosine of our double angle. When I think about the double angle formulas, we have 3 formulas from which to choose. I only know a cosine value, so I'm going to choose the one that only needs cosine. If you're looking at the front poster, that's the second formula. If you're looking at the back poster, it's the third one. I don't know why I couldn't get them in the same order. But that formula tells us 2 cosine squared x minus 1 is the same as our double angle theorem for cosine. Cosine x, it tells me, is negative 0.4. I need to take that value and square it, and I need to do it in parentheses. Here we go. 2 times negative 0.4 squared, and then subtract 1. 0.68. Negative 0.68. Now again, this might be another one where we can end up with a value that we know. It might tell us a weird decimal or something on our calculator when we find this out. If you can, or if you need to, turn your answer into a fraction if we can get a more exact value that way. This one is also happens to be in a fraction, negative 17/25. We could look at it either way. So we took a look at what we know, and we chose the cosine formula that let us use what we know without having to find something else. When we look at our last one for today, we'll finish off this page altogether. We're looking for a sine of a double angle. We need an exact value. Take a second, please. Put a negative out in front here. I skipped that negative symbol, so we need that. If we're in quadrant 2, our cosine value should be negative. Sine of a double angle, we only have one formula, and we're stuck with it. So let's go ahead and see what we have and what we need to know. Our sine of a double angle tells us it's 2 times the sine of the angle times the cosine of the angle. I know the cosine of the angle. It tells me it's negative root 13 over 7. What I don't know is the sine of this angle. But I'm not stuck. I can still calculate that. I'm going to draw an angle up in quadrant 2 like it tells me. Up in quadrant 2, I have a cosine value. Cosine is adjacent, negative root 13, over hypotenuse, 7. I need to calculate the missing side of my triangle. Go ahead and calculate that missing side using Pythagorean theorem. And what is the length of side B? 6. Fantastic. If I find that this length of this side is 6, I'm ready to find the sine of this angle. Sine is opposite over hypotenuse, 6 over 7. And now I'm just multiplying some good stuff together. All right, so I now have 2 times 2 fractions, so I'm just going to take just my first 2 together. It's okay if you can multiply them all at once. We will stay with an exact value, but I have 12 sevenths, and I'm still multiplying it by negative root 13 over 7. When I multiply these straight across, a negative times a positive is negative 12 roots of 13, and I do multiply my denominators to get 49. Can I simplify negative 12 and 49? Can I simplify square root 13? I can't. So my final answer, negative 12 roots of 13 over 49.